Hello everyone, my name is Kanchan Dikshit and I am working as an assistant professor in the Department of Computer Science and Engineering in ABES Engineering College, Ghaziabad. So today I am going to discuss about deadlock handling. Deadlock is a condition which should be handled in the in process synchronization, because if deadlock will not be handled, then no process will be able to execute itself. So in previous video I have already discussed about the deadlock, what are the necessary conditions for the deadlock, and what is resource allocation graph. Now, these four are the methods to handle the deadlock: deadlock prevention, deadlock avoidance, deadlock detection, and recovery from deadlock. So there are total two type of possible ways to handle the deadlock. In first way, either we can prevent the deadlock or we can avoid the deadlock. These two method will work for before the occurrence of the deadlock. But after occurrence of the deadlock, we need to detect it, and after that, we need to get the recovery from the deadlock. So, in the perspective of deadlock prevention, we can have total four necessary conditions for deadlock. These all four should be there to say that whether there is a deadlock or not. But if we are able to prevent the system from any one of the condition, then we can say there is no deadlock. So mutual exclusion could be, I can say, for mutual exclusion, there is the resource that we can say that the resource we can make non-shareable, right? For for fulfillment of mutual exclusion, we are having the non-shareable resources. So what we can do, we can go for the shareable resources. How can we do it? Because if sometimes there is a file that is requiring the read operation from any process, so we can make it shareable by making it readable file, right? So these are the options where there will be no logs required for the uh, access of the resource. Now, the second condition, we can say there is hold and wait. So in this condition, the process is holding any any resource, and it is trying to get access of other resource. But to uh, to prevent the deadlock with the help of this condition, what we can do, if P1 process is having R1, right, and it is requesting for R2. So what can we do? We need to go for the method like this, that if any process is requesting for any resource, then it needs to go for release of all the resources first, and after that it will start afresh by requesting both of the resources. So P1 will release its resources that it is holding, right? And after that it needs to uh, request for both of the resources. R1 and R2 will be requested by P2. So these two conditions we can avoid with these two methods. Now, if we talk about no preemption, so no preemption will have the same method like so. In this no preemption, what we can do, we have to make the rule like if any process is not getting the resource acquired by or approval from the system, then it will have to release all the resources, and it will again request for the all of the resources it required for its execution, right? Release all the resources and then it will request, again request, right? Now, what is circular wait? Now, in circular wait, what we can do, if there are two processes, P1 is waiting for P2 and P2 is waiting for P1. So what we can do, if P1 is waiting for P2, because P2 is holding resource R2 and P2 is waiting for P1 because P1 is holding R1, right? So what we can do, we have to make a sequence of resources. Like what? R1 should be requested before R2, right? So how it will be possible? Like if any process will have R1 already allocated, then only R2 could be allocated. So this is the sequence that first each and every process will try for R1, and when R1 will be allocated to any process, then they will go for the request on R2. So these all four conditions could be avoided with the help of these methods. Now next, deadlock avoidance. In deadlock avoidance, what we have three total methods, like safe or unsafe state, then banker algorithm, and then resource allocation graph. So resource allocation graph we have already done. Like in this, we have to show the resources are allocated to the processes. Like in processes will be represented with the help of circle, and the resource allocated to it will be having the edge that will be directed from R2, resource to process, and the process is requesting for the resource like R1. So requesting edge will be directed from process to resource. In this way, this will be the allocation graph. Now, banker's algorithm. What is banker algorithm? Banker algorithm will be used to find out the safe sequence. Safe sequence is what? There are processes like P1, P2 and P3. So we need to find out a safe sequence in which way we have to execute the processes so that no process will have to wait or there will be no deadlock. So this algorithm will be used for the safe sequence. So I will make the separate video for banker's algorithm and its numerical. Now, what is safe and unsafe state? Safe state says that if there is a safe sequence in the system, if safe sequence exists in the system, then there will be the safe state. Otherwise, it will be unsafe, right? So what we are going to do, we just need to find out, like if P1 has R1 and it is waiting for R2, right? And P2 is already having R2 and waiting for R3. Like P3 has R3 and waiting for R1, R2. So what we have to go for, like the P1 is waiting for R1 and R2 both. So it needs to release its resources so that P2 could be completed, and after that P1 could be completed, and after that P3 could have R1, R2 and R3 all of the resources. So what will be the sequence? P2, P2, then P1, then P3. So this will be the sequence, right? So this is the safe sequence that we have to find with the help of banker's algorithm. Now, the next is after deadlock. We are having two methods, deadlock detection and recovery from deadlock. In deadlock detection, there is wait for graph and single and multiple instance of each resource type, right? So, deadlock detection occurs when we are not able to prevent and avoid the deadlock, right? So, we have to detect the deadlock. For the detection of deadlock, we have to make a algo which will be iterated after a point of time. So, suppose after 5 seconds, the algo will be having execution. So, what there will be? Yeah, there will be the system, right? We have to make the algo to find out if there is any deadlock or not. And as soon as the deadlock occurs, if yes, then it will be recovered or recovery from deadlock. This method will take place. Otherwise, for no condition, if no deadlock occurs, no deadlock is there, then after 5 seconds, the system will again run the algo. So this is what, this is the deadlock detection algo that will run after an interval of time, and then as soon as it finds the deadlock, it will go for the recovery from that. So there are two types of resources. The first one is the single instance of each resource type, and the other one is the multiple instance of each resource type. So there are two instances, single and multiple. So what are these? These are like, if there is any resource R1, it is having single instance, so it can be allocated to one process at a time. But if there are two instances of any resource, then at a time it could be allocated to, the first one is the single instance of each resource type, and the other one is the multiple instance of each resource type. So there are two instances, single and multiple. So what are these? These are like, if there is any resource R1, it is having single instance, so it can be allocated to one process at a time. But if there are two instances of any resource, then at a time it could be allocated to two of the processes, it could be allocated. So this is the difference in between multiple instance of each resource type and single instance of each resource type. Now, how to handle these two different variants? So for single instance, we can say we are following for the wait for graph. So what is wait for graph? As I have already told you, like P1, suppose this is the resource allocation graph. P1 is having R1 and R1 is, P1 is having R1 and P1 is requesting for R2. And R2 is being allocated to P2 and P2 is requesting for R1. So this is the resource allocation graph. So in simple way, what we need to know, we just need to know that P1 is waiting for which resource, which process. And suppose R2 is being requested by P3 also, right? So P1 is waiting for the resource R2 and R2 is held by P2. So P1 is waiting for P2, right? And P2 is waiting for P1. And there is P3 also. So P3 is waiting for R2 and R2 is held by P2. So P3 is waiting for, P3 is waiting for P2, right? So this is the wait for graph. This is the wait for graph. Now if we talk about the multiple instances, so for multiple instance, we are using the banker algorithm. I am making the separate video about banker algo to find out the safe sequence. So there is the system. The system will run banker algorithm after a particular time interval. And if there is the safe sequence that is found by banker algorithm, then there is no deadlock. So this is about the deadlock detection. Now, what is deadlock recovery or recovery from deadlock? So there are total two possible methods. The first one is the process termination and the resource preemption. The process termination says that we have to abort one process at a time so that the processes could execute itself. So process is holding some resources and that could be released by the process, so that we can have the resources to give or to approve by for the request by the other processes. Now, till when we have to go for the process termination, we will abort one by one processes until the deadlock is not there, right? What is about the resource preemption? Resource preemption could be done with the help of selecting a victim. Either we can have one resource, we can select one resource, or we can roll back. Roll back means if we have just uh, approved any request on the resource, so we can have rollback. Okay. Now, what is starvation? Starvation means is if there is any one process that is starving by the resource, so we can have the resource preemption for it. So thank you so much. This is all about deadlock handling. In the next video, I am going to share about the bankers algorithm.